we have this evening Kit Franklin, who is a leader, probably the leader in total farm automation. And he comes from the, what should I say, the alternative or a competitor with the RAU, Harper Adams, where he's been leading this first in the world, I think, isn't it, Kit? The hectare, which has not been touched by hand, it's been farmed from the first moment of sowing right through to harvest, I believe.
Yes.
And he has now moved on to managing a bigger project, which is a complete farm. Yeah, absolutely. Yeah. Basically conventional farming, but completely automated. So without saying any more, welcome to Kit Franklin, who's come to talk to us this evening.
Brilliant. Yeah, thank you very much, everyone. I'm going to apologise straight up. I've got an awful lot of slides. I do go quite quickly. I'll try and be clear with my quickness, but I'll be clicking through fairly rapidly. And if I start slowing down, cough at me to speed up because there's lots to go through. So I've got, and just because we're here, I'll just say I've got a few interesting backstory, not interesting backstory really, but my backstory is I am from Cirencester. So I was educated at King's Hill, then at the college. I spent a lot of my Saturday mornings actually in the building next door where I used to come for learning support lessons to learn how to read and write, which I was very bad at. I then obviously went away from Cirencester, where I went to Harper Adams as an undergraduate student to study a master's in engineering. And then I kind of never left until October last year, where I then moved home. So I'm now living about 2 miles away from here in Coates. And I started my life here as well, but, you know, I've been away mostly in the meantime. Great. So I'm going to talk to you about what I do, which is hands-free farming. And again, when I talk to sort of science groups, I have to try and build up my credibility. So I'm a senior engagement fellow these days. And I'm currently the vice president of the Institution of Agricultural Engineers as well. So I have some credibility, I hope. So this is where I'm from, or not where I'm from. I've just told you where I'm from Cirencester. This is where I work, and this is Harper Adams. It's not quite as old as the place we're sat. It was built in 1902 for the purpose of educating in agriculture, with money left by a chap called Thomas Harper Adams, hence the name Harper Adams. I work specifically in the engineering building. And despite us not being a huge university, we do quite well in our ratings, and we're often, you know, given quite good prizes and things like that.
Where is it?
Where is it? Very good point that I haven't made. We're in Shropshire, so North Shropshire on the Shropshire-Staffordshire border. We're a little bit bigger than here. We've got about 3,000 students on campus at any time. So yeah, it's a slightly bigger place, but very similar in its aims and objectives. Okay, so this is the start of my lecture proper then, I guess. So what is agriculture? I like to always start with this statement of what is agriculture, because I think it's a really important place to start, obviously. Start right at the beginning. And for me, it's the ability through the application of science and technology for the few to feed the many. And it is a continuum. So if we take this graph, which is a snapshot of the last 100 years here in the UK, we've had a population grow from 45 million up to 65 million. And we've had on-farm staff drop from 2.5 million down to about 500,000. So 100 years ago, that represented 5% of the population of this country, growing the food for 95%. And now it represents 1%, growing the food for 99%. If you take this continuum back, some touch points, you know, I've got, I think, if you sort of try and research how many people are involved in agriculture in the Roman era, it was something like 75 to 80% of the population used to grow food, and the 20% used to go around fighting each other. So this sort of sliding thing has continued. So how has the last 100 years of development been achieved? It's been achieved through, one of the big ones is through the adoption of mechanization. So the tractor as we know it, and obviously as an agricultural engineer, this is very important to me. But also this image to me represents some other things as well. This shows ensiling of grass, so we can keep grass over winter to feed our animals. And this is a technique that was developed in the last 100 years, again allowing one person to manage more animals and more livestock with the use of this ensiled grass. We've used ag chems. We can have the debate if they're good or not, if you'd like, but I'm a pretty big fan of ag chems. I think this is supported probably, you know, half the population of the earth is basically supported by the fact we have embraced agrochems. We might want to move away from them in the future, and we'll talk about that a bit more in a bit, but we end up with lovely, clean crops that yield very highly and fertilizer that also helps that process. So lots of technology that maybe 100 years ago, you wouldn't have foreseen. And this has been great because we've been able to drive our yields up. So yield per hectare has gone up and up and up over the years. We'll come back to that graph in a bit. So what are the challenges to come in the next 100 years? Well, we obviously have this continuing growing population. Where that goes is obviously slightly debatable. And some people are even now starting to talk about population collapse being a real possibility. So who knows where that quite goes, but for the time being, it's increasing. We obviously have climate change. Again, exactly where that goes is probably up to us, but you know, it will go up. And as farmers, as an agriculturalist, we have to feed this growing population whilst the climate changes. And as somebody who grows things in a field, you're going to be very much affected by that climate change, whilst also being expected to mitigate it by sequestering carbon and building biodiversity, et cetera, in this sort of race to net zero. So as farmers, we have to both cope with climate change and mitigate climate change. How are we going to meet that challenge? Well, the way that I look at how we're going to meet that challenge as an engineer is through quite an engineering means, and this thing called precision farming or precision agriculture. And precision agriculture is kind of exactly what it suggests it might be. It's about doing the right thing at the right place in the right time and in the right way. It's all about attention to detail. And rather than managing whole fields or even whole farms the same way, it's about breaking our areas of land down, or about breaking if we have herds of animals or flocks of sheep or whatever. It's about breaking it down into its constituent parts and trying to be more and more exact with the inputs that we put into the system. So by being more targeted with our inputs, we can reduce our waste, increase efficiency, and overall improve the sustainability of our farming. So this is the aim of precision farming, which has been a concept that's been around for since around 1992. And I say, precision farming is often talked about as a technology, but for me, it's not a technology. It's a management approach for which technology assists. So what are some of the successful techniques that have been embraced under this term precision farming or precision ag? Well, the use of high precision differential GNSS, global navigation satellite systems, colloquially what we would call GPS. But GPS is just one brand name, essentially, of multiple types. In fact, there are 4 constellations of navigation satellites, one by Americans, one by the Chinese, one by the Russians, and one by Europe. How it works is we have this constellation flying around, sending down highly accurate time signatures. And all we receive as users of GPS, or GNSS, as I should say, is a timestamp. And by comparing that timestamp to the time that we know it to be on Earth, we can calculate the distance at which that signal has traveled. So if the signal leaves the satellite at 1 o'clock and it arrives at 1 minute past 1, we can deduce it's taken a minute to get there, and we can use that to work out how far. Clearly, it's not in minutes, it's in nanoseconds or whatever. And this allows us to trilaterate, not triangulate, as many people will say, where we are on the Earth. Now, the problem is, when we trilaterate our position, it's highly affected by refractions in those signals reaching us. So if those signals are bent, twisted, warped, bounced on their way to us, that's going to increase the time it takes them to come to us, and we will then fail to have an accurate position. So that's why when you turn on your GPS for the first time, if you get out of the tube station in London, you will bounce around and ping around until it works out where you are, because it's literally, the signals are literally bouncing off the buildings around you. And as normal users in everyday world of GPS or GNSS, we're pretty much happy with maybe 1 or 2 meter resolution. But in farming, we need to be much more accurate, because I want to know exactly where every single one of my plants in a field is. So in order to do that, we do a thing called differential GPS or GNSS, sorry. I make the mistake all the time, same as everyone else. And this is basically a very simple system, which I will explain through the medium of dance-ish, that basically requires you to have a known location, base station. And if you know, and you absolutely know the geo position of a base that then runs a GPS receiver, calculating its position continually, it will calculate a position that jumps around because of the errors in the ionosphere as that signal reaches us. But what we can then do is go, well, if I know I'm here, but I'm calculating I'm half a meter over there, I can use that error, and in real time, I can broadcast that to a user of the signal, and I can correct the user in the field. So this is done at regional level, and there's this technology in Europe called EGNOS, which is a regional-based correction, which allows you to get to maybe 30 to 50 centimeter accuracy, which is pretty good, but it's not perfect. But if we use a thing called RTK, it allows us to literally get to 20 millimeters accurate. Day on day, week on week, month on month, year on year. If I position a point on the ground using proper, full fat, localized correction, I can come back to it a year later and I will find the peg I put on the ground. And this allows us to do some cool stuff. It allows us to drive tractors and drive up a field and miss loads of rows and then come back and fill those rows in. It allows us to drive tractor across the side slope and account for the drift of the machine down the hill and put the machine in the right place. You may say, what's the point in that? Well, the point in that is this is giving us perfect coverage of the field. And this can, going back to our precision thing, this has the opportunity to save, because of overlaps, you can often save 5 to 10% of your inputs by just getting rid of overlaps in your field. So you're talking about sustainability, this is a 10% win straight away by adopting this tech. Taking it further, we can take that same tech and we can put it on a sprayer or a seed drill, and we can now turn off individual application nozzles based upon where they are across the boom, so we do not get any double spraying. So we don't want to overlap our spray and double dose anything. That's very bad for the environment. It's normally quite bad for the crop too. We also, if we have any buffer zones or no spray zones, we can also ensure we don't get any chemical in those areas too. So when you hear, you know, as somebody who is an advocate for farming and pushing farming forward, when you hear sort of terminology where people talk about, you know, farmers, you know, throwing chemicals around and this sort of stuff, it really riles me because it's just not true. It's very, very important that we're highly accurate with where we put our chemicals, and a hell of a lot of technology goes into making sure they go exactly where they should go in exactly the right amounts. And this, once again, can save another 10 to 15% of your sort of chemical expenditure if you use this sort of technology, and already exists. Furthermore, then, we can also do stuff that doesn't rely on chemicals at all or satellites, and this is a vision-guided hoe. So I love it. I do like a good reaction to this video. I'll see if I can play it again. Can I play it again? There we go. So this machine is called a Garford RoboHoe. It's using very basic vision systems to identify the lettuce and basically grid the lettuce, and anything that it thinks is not a lettuce because it isn't green and it doesn't fall in this perfect grid, it destroys, basically. So it's really basic. How long has this piece of equipment existed for? Any guesses? 10 years? It's a pretty good shout. Yeah, this machine has actually been on the market since 2005. It's a British piece of machinery developed by British engineers. Very proud of this. You know, it's got nothing to do with me, but I'm always proud to show it. It's but you know, and when I show it to people, machine vision sounds like a very sort of last handful of years sort of thing. A lot of people will go, oh, it must be like 4 or 5 years, machine vision, it's real high tech. No, in farming, we've been doing machine vision for years. Cool. So let's move away from what's been good and let's talk about some more things that are bad. So what we have on farms currently is a mechanization problem. We have a reducible labor force that has led us through a cycle of sort of mechanical evolution to a place where we have very, very large machines, which allow one person to do a great deal of output when they farm. Sorry, I'm just trying to find where I've got to on the thing. As well as that, as well as that reduced real labour force, our farms have also conglomerated and got bigger. And that's had the effect of making our time windows when we go farming effectively sort of shorter. Because now, a farm 50 years ago would have had 2 weeks to drill 200 acres of crop. And now they will have 2 weeks to drill 600 or 700 acres of crop. So we have these limited time windows. And again, this has pushed us to take on bigger and bigger machines. We have one-upmanship. Farmers love looking over the hedge at what the farmer next door has. And if the farmer next door has got a bigger, shinier tractor with a bit more chrome on it, then sure enough, they're going to go and buy a bigger, shinier tractor next time and put a bit more chrome on it. And it is true. This is the easiest marketing strategy in the world for ag manufacturers, that they must make the next bigger machine with the next bit of chrome on it, and it will sell. Now, that's all been great. It's allowed us to use less people to grow the same amount of food. However, we have a lack of resolution for this thing called precision farming. This machine here is a combine harvester, and this image is showing us a sort of artist's impression of a yield map. So this is a map that shows you where in your fields you have high or low yield. Now, reality is a yield map is not as granular as that marketing image would like to show, make us believe. A yield map actually looks more like that. It's like a list, it's like a line, it's like a barcode, because we only take one yield sample for the width of the combine header. And we geolocate that in basically a line of blocks. Now, the problem is when yield mapping came into existence in about 1995, when the first satellite systems allowed you to locate yourself in a field, not at very high precision at that point, it was quite rubbish precision, but still, the header on a combine was about 6 meters wide. So your resolution of your data was 6 meters. Now you can go into the Class dealership next to Cirencester Market out by South Cerning, and you can buy yourself a combine with a 14-meter header. So your resolution when you get your yield map is now half as good as it used to be. Further to this, these very large machines have caused a breakdown in our soils, compaction in our soils, which has limited yield. And this is where I bring this same graph up I showed you earlier, because although it looks as though this is increasing this yield, if you look to about the year 2000, since then, this graph has flatlined. We've had no increase in yield, no sort of marked increase in yield for 20 years. And why is that? Well, mostly it's because the soils are in a pretty bad state. And in this case, you can see a full crop failure, where basically this bit of land here has been driven on by too much heavy machinery, which impedes root growth and stops anything growing. So, is the future a small robot paradigm? The idea here is, if we weren't limited by that human resource, if we weren't limited by the people driving the tractor, we could increase the resolution at which these machines work. We could shrink the machines, improve the resolution, improve our precision farming. When I was saying earlier where we had sprayers that are now 10% more efficient, well, maybe we could get to the point where our sprayers were 70 or 80% more efficient, because they're only targeting weeds on an individual basis. They would also reduce compaction, because these tiny machines that I sort of liken to these imageries is like a vacuum cleaner or a lawnmower. They don't weigh very much. We can put them on nice floaty tires, reduce our compaction, unlock the yield plateau. These robots can operate in swarms. So rather than one massive machine, we can maybe have 10 of these in a field. These swarms require management. So, again, as someone who's involved with robotics, you get told off for putting people out of their jobs quite often. So, maybe that person doesn't want to sit on a tractor seat anymore. Maybe they want to manage a fleet of robots. Maybe that's actually a more attractive task if you go and talk to a 17-year-old, especially if you're trying to attract people from outside of your own industry. Small vehicles are intrinsically safer. If I automate the 30-ton quad track tractor that I showed you on the last picture, on the last slide, and something goes wrong, it's going to go AWOL. It's going to drive out the field. It's going to break down the wall if we're here in the Cotswolds. It's going to drive through the ditch, through the hedge, across the road, through the house, kill the inhabitants. And we won't be farming with robots for very long. If I automate something the size of a vacuum cleaner, it hits the Cotswold stone wall and the story stops. So we have an intrinsic safety benefit if we're going to automate stuff, to automate small things. Now, just to put some numbers on another reason why this might be sensible, if we plow a hectare of land, we will move in the order of 1,900 tons of soil per hectare. So on a continual basis, you're moving all this mass of earth. If we just took a small robot and put some sort of drill bit injection device on it and just drilled a hole and injected a seed, we can move as little as 12 tons of soil, 11 or 12 tons of soil per hectare to establish a crop. So if we've moved 150 times less soil, have we moved 150 times less? Have we used 150 times less energy? Well, we're probably getting somewhere close to using a lot less energy. So now I will show you a picture of a TE20, because these ideas, everything I've said to you so far is nothing to do with me. This has got nothing to do with Kit Franklin. This is just me parroting ideas of my predecessors who came before me in the 2000s, really. And I picked up on this work in about 2011, 2012, when I started doing this work. And the problem was, I believed all these things I've just talked you through. It all seems pretty logical. I wanted to reinvent agriculture. These things seem pretty logical. The problem is, as someone from a farming background, this machine sort of makes me a bit cold. This image doesn't fill me with confidence that it's going to replace the tractor anytime soon. And when I spoke to farmers, they felt exactly the same. They would switch off. Now, if I show a farmer the picture of the TE20, they feel all warm and fuzzy inside. I feel all warm and fuzzy inside because I'm showing them the first tractor they ever drove. And this is where I started to go, well, we didn't really have compaction issues in the 1950s. You can't find much literature talking about compaction in the 1950s. And we were using smaller implements then that had better resolution. So rather than, when we're having this discussion about agricultural robotics, rather than have a discussion that's based around sci-fi imagery, why don't we have a discussion that's based around smaller tractors that are relatable to farmers? And that's where Hands-Free Hectare came in. So this is where I guess, add some value to my own story. There's me as a student in 2012 making an agricultural robot. My agricultural robot was exactly as successful as every other agricultural robot that had come before it. And that success was this grainy video of it driving around a rugby pitch. It never made it into a field. It never did anything useful. And it certainly didn't do any, farming. I was working as a researcher and I met this chap. This chap here is called Jonathan Gill. Jonathan Gill is what I affectionately call a geek or a nerd. And he spent his life in the open source community hacking mobile phones and turning them into flying machines called drones. Now, these drones were highly effective, far more effective than my fairly rubbish robot. And they were really reliable. They could come out the box. You could plot a plan just like this, and off it would fly and come back to him. And there you go. John was a hero with these flying machines. And I basically said, could we take your tech and could we put it into my world of farming? Now, while we were having these sorts of conversations, I was beginning to get very frustrated with the progress of agricultural robots because I feel like I want it to work, but if I Googled ag robot, it would come up with this picture here. This is genuine, right? 2014, 2015, Google agricultural robot, and this is what you get. A bunch of student university projects from across Europe in a thing called the Robot Challenge. I should know that, I've been. It's hosted every year. Universities from all over Europe enter, but this is what the image of agricultural robots was. Didn't exactly fill in with very much confidence. The robots that were being generated, this one here being an example at Harper, I think this cost $500,000 to get to the point where it drove around a rugby pitch, same as everyone else. And then we were doing some really funky things in our lab. This is my lab at Harper. And we were doing really clever stuff, but I wasn't allowed to tell anyone about it because unless you were Jeremy Corbyn or a politician or high-ranking person from DEFRA, it was all top secret. So I would sit in the pub and I'd talk to people about what I do, and they'd tell me it was all a load of rubbish and never going to happen, despite the fact I had it in the lab working. So this made me and John scope a project that was all about engaging the public and being open and sharing the results and pushing the story on. So we set ourselves a challenge of being the world's first people to grow a crop entirely using autonomous machines. The deal was we were going to use off-the-shelf farm equipment. We weren't going to reinvent the wheel, but it was going to be small scale, but relatable farm equipment. We were going to use Jonathan's open source technology. We were going to use social media to publish our story as it went through. So we would take people on our journey with us. And no one knew who we were. So how did I get funding? Well, how I got funding was by being like, really slightly cheeky. So I rang up lots of companies. So Precision Decision is the main one. I actually got the guy who ran this company called Precision Decision, I got him fully on board. He really liked what the idea was. But these companies here are some of the biggest companies in agriculture. And I rang people that I knew at all these places. And I basically said, oh yeah, I'm going to do this project. It's only going to be a hectare. If I grow a hectare of crop, KWS, will you give me some seed for a hectare? They're like, yeah, go away. You can have some seed for a hectare. That's nothing. Real, can I have some fertilizer for a hectare? Of course you can have some fertilizer. Go away. We've got other things on. Had all these phone calls. In my application for funding, what did I say? I have the full-fledged support of KWS, Yara, Bayer. They all know me. They think it's a great idea. Okay. But I say that because it's funny, but it's true, right? I was a 26-year-old that nobody knew, and I was pitching for government money to do a crazy idea that was very likely to fail. The only reason I got that money was because I had a little bit of a, I guess, is it a brass neck? Would that be the right term? Something like that. So, okay, what did it look like then? Well, we took our money and we started off by prototyping on little radio controlled cars. We then integrated it into much bigger things, a tractor. We also got a combine harvester, and all these things were pretty cheap and easy to come by. I'll try and do some speeding up. I've gone quite slow. But yeah, this is the sort of journey. And we shared all this real time on the internet. The tractor was very cheap, but it was free to us, but it's actually a very cheap machine. The adaptation of the controls is really Heath Robinson. We took the most basic machine we could. It's not an electric controlled tractor at all. It's all levers and linkages. And we replaced the human arm with linear actuators. We replaced the human arms on the steering wheel with a motor and a belt, all really basic tech, but linked to this open source control system. And this is what it looked like in terms of the stuff of how it worked. It's on GPS. Here's our GPS coming to the cab. This is our RTK mast I described earlier in dance, and sending that error signal to the tractor. We've also got telemetry through Wi-Fi, so we can keep an eye on what's going on. We produced plans of basically waypoints, breadcrumb trails around our field that the tractor's going to follow. We have a laser scanner on the front of the tractor, so if it gets anywhere near a fence that we put around the field, the tractor will stop and won't crash through the fence. Again, another thing I forget to say these days is that, now I'm really blasé about this. We go out in the field with a robot tractor and everyone knows it works, and no one's really on my back anymore. 2016, everyone was telling me we were going to kill people. Basically. What happens if your tractor goes AWOL? What happens if the amount of risk assessments and all sorts of stuff I did to get this off the ground was incredible, compared to now where everyone just goes, oh yeah, it's great, your tech. This is what it looks like. This is what it looked like. So we got the funding in October 16. This is March 2017. We had already, in 6 months, went from nothing to a tractor that could drive itself around a field and plant some crops. That development cycle is faster than anything I've ever witnessed in any other project, and I've been involved in quite a few. And it's not because we were really clever, it was because this open source technology is freely available and is in itself really clever. We just applied it to our world. So here we go. We drilled a crop, we rolled a crop, we had a scout vehicle to go and grab us bits of crop. So no one could go in the field, not even our agronomist, our crop doctor. We got a sprayer driving through. And what you can see here is quite how ropey my crop looks. Look how awful that is. But I'm incredibly proud of this crop. This is the world's first fully autonomous crop. And it's awful. But people were pleased to see it nonetheless. We proved the point. We proved that 3 people with a pretty small budget, with a good attitude, could make something happen. But as I say, it wasn't perfect. So there it is. That's at harvest. And that's the point where we really had done a world's first. So other people had done bits of it. People had drilled a bit of crop. People had harvested a bit of crop. But no one had done this full package. Why did it drive in such irrational lines? I'd like to try and drop in a little bit of tech to when I'm talking to science people. I am mostly just a hand waving, I don't know, but I can be a little bit technical too. So here we go. If you're an open source community person, if you make your radio controlled car drive from point A to point B in your garden, you're pretty happy. Do you mind if it deviates by, you know, a few hundred millimeters? No, not at all. We took that same tech, put it into a tractor. Now imagine the GPS receiver on our tractor is 2 meters in the air, 2.5 meters in the air. And now you tilt that tractor when it goes down a little bit of a divot in the field. The GPS receiver thinks now that it's a foot, you know, 200-300 mil from where it should be, even though the tractor is actually on course. And what happens is the algorithms developed by the open source people who were just driving radio control cars around gardens makes the tractor chase back to where it should be. So it spends its whole time overcorrecting itself. Okay, and this is the issue we faced in year one. And we didn't have enough time until harvest. So you see the combine drove a lot better. We didn't have enough time in year one to correct these issues. It was on this little thing. This was called an Earl Brain. It's a little shield board. It goes on a Raspberry Pi. This setup here is about £100. Any of you can go and buy this and replicate what we did. It's not hard. Whereas it's not hard if you can code. I can't code. I have colleagues who are good at that. Jonathan and Martin, they're very good. But yeah, it was in this thing's capability to do much better. We just didn't have enough time to make it much better. Just needed iteration. So we got some funding to do it a second year, and this is 2017, and you can see here the crop and all the holes in our crop. And this is 2018, and I'll show you the video of it in just a second. But you can see how much better that was. We've got rid of all these holes in the crop and all these wheelings. Now, what's really important to me is this little fact here. So in October 17 through to March 18 at Harper Adams, it rains a lot at Harper. It's not like beautiful Cirencester. And it rained 117 days of 160 days. And on the 14th of March, we needed to put some fertilizer in our field. Everybody in the local area missed their fertilizer timing by at least a week because the soil was too wet, fields are too wet, blah, blah, blah. Our little tractor, which doesn't weigh anything, weighs like 1.5 tons compared to 8-10 tons, drove across our field without leaving a mark. So this, to me, is the benefit of smaller machines. We didn't miss our timing, which is critical in farming. So here it is. This is what year 2 looked like. Here's our tractor going across the field. It's not as fast as that, that's sped up, but it is a little bit faster. It was faster than it was year 1, and it was certainly straighter, and you can see there the coverage is much better. I should say you can tell one of the guys was really keen on drones because we have all the sweepy drone shots and all that stuff. Yeah. And there we go through to harvest, which was all very good. In fact, I'll just keep it running for a little bit longer. Because there we go, we unloading on the move. So to agricultural people, this is what they want to see. 2 machines driving next to each other, unloading on the move. This gets my students excited. Okay, so now again, I guess some of the key learnings for me, and I started off by telling you I was dyslexic, which I wouldn't normally do. That's something I wouldn't normally do. It's only because we're here and I used to get lessons just across the way. But one thing I want to do is I want to write a book about this stuff. Nothing to do with hands-free, but about collaborating for success. I've been involved in a lot of collaborations, and the reason that hands-free worked was for a few reasons. We had a fully integrated collaboration. So this chap here is called Martin Abel. He worked for Precision Decisions, and this is Jonathan Gill, my colleague at Harper, and the 2 of them worked in the same room, in the same building for a year to make this happen. This wasn't collaboration where one was at one office, one was at another office, and once every 3 months they met up and did the things, talk to each other. This was true integration of people. And we worked in this integrated, and I like to call it skunkworks team. We were all pretty young, we were all pretty inexperienced, and I somehow managed to convince my bosses that they would have never been as ambitious as we were. So once we got the funding, don't meddle with it, because you would have never got the funding if you had meddled with it. So now I've got the funding, can you just leave us to it? And no one got involved. So I was allowed to head my own work. There's professors walking around who weren't allowed to claim my work. That's quite unusual. Professors love claiming the work of 26-year-old researchers. But I didn't let them. I kept hold of the ownership of my project. And that was really important to me. honest weekly progress meetings. So this picture here, yeah, this is just a little progress report. It's really basic. This is nothing. In the world of project management, this is rubbish. But we filled it in truthfully. We were honest when things were late. We were honest when things were on time. We were honest about risks. I've been in so many projects where people have far more complicated systems, but don't actually use them correctly, and therefore things get missed. Okay. The last one is time and reputation pressure. I started off by telling you we shared all this on social media. If you read a press release from October 2016 on the Harper Island's website about hands-free, you will never read something from some as sort of arrogant, sure-footed young men as that. It's incredible. We're like, yeah, we're going to do all this stuff. It's never going to go wrong. I read it now. I can't believe we were as confident as that. We set ourselves up for a huge fall. But what that meant is that we did a lot of work and we worked a lot of hours and we put the effort and time in. And as I say, because it was my name attached to it, and because it was John's name attached to it, and because it was Martin's name attached to it, we didn't want it to fail. So that's the reputation pressure bit. The time pressure is when you're doing farming, you've got this thing called the seasons. And time moves and you have to be there. If we weren't there at the end of March to drill a crop, the whole project failed. So that real, true, immovable time pressure is immensely important. The rocket signifies this reputation pressure, because this is what I liken us to. When NASA say we're going to launch a rocket on whatever date, people tune in to watch it, and it's a bit of a disaster if it doesn't. And that's what we did. We said we're going to drill a crop on the 29th of March. We're going to drill. I've just made that up. I can't remember the date. We're going to drill a crop on this date, and journalists turn up to watch. So we better blooming work, otherwise we look really silly. Okay, so the impact of this was good publicity. I'll go over this really quick. You know, we've got lots of followers. These are small numbers for social media. Some of you will know social media, some of you won't. But these are pretty small numbers, but they're big enough that it was noticed by the BBC. It was noticed by CNN, New China, and it went all around the world. 85 plus countries have written about this stuff. I've been in mainstream newspapers. I've been in agricultural magazines all over the world, thanks to the fact we just pushed stuff out on social media and it got picked up on. And obviously, once you get in the BBC, once you're on the BBC front page of their website, on the BBC News, obviously the rest of people will look at that and it spreads. But the only reason we got on the BBC website is because we had a Twitter account and a journalist at the BBC saw it. Okay. So how do we keep it fresh? Well, we kept evolving the story. We grew 4.5 tons of barley the first year. What do you do with that? Well, you make hands-free beer and you do a press release based around the fact you've got now robotic beer. Then you make some gin and you have robotic gin. I was lucky enough to be presented robotic gin at my wedding. I didn't know anything about it. My colleagues sorted this out secretly, and then I was presented robotic gin to drink at my wedding, which I would get slightly choked about, which is really weird, but it's quite cool. I had some good fun. Yeah, we won awards. Every time you win an award, do a press release about it. If you win another award on the BBC, you get some radio airtime and you do a press release about it. You know, so we just kept pushing it. You get Jeremy Corbyn to your field. What do? You harvest some grain with an autonomous combine. You mill it in front of him. You put it into a pizza oven and you feed Jeremy Corbyn a pizza. Yeah. And it doesn't matter what you think about this chap. He spent an hour on the side of my field talking to me about farming. This is the man referred to by Boris as the Islingtonian herbivore. Didn't spend much time on farms in his tenure as leader of the Labour Party, but he did spend some time at my farm. And yeah, for the agriculturalists, let's do some unloading on the move. Political stuff. Here we go. Gove's been to see it when he was head of DEPRA. Owen Patterson, before he was disgraced, used to come and see us quite regularly because he's local. Smart Warport was the chief scientific advisor. This is me. I'm always wearing the brightly coloured trousers. He came to see us. We've been talked about. This is Princess Anne talking about us in London. This is Gove talking about us at a conference. We made it into DEFRA's Green Brexit paper as a case study. So we had quite a lot of impact. But that led on to people saying, well, my farm is bigger than 1 hectare. It's not flat, it's not square, it looks like real farms. Why doesn't yours look like a real farm? So we found ourselves 35 hectares of land at Harper Adams. All of the fields are different shapes and sizes. They have all the problems that real farms have. So we have telegraph poles. This field is called Pause Land. It has 5 telegraph poles, 2 manhole covers, and it doesn't have a straight hedge in it. So this is as real farming as you can get. And we had to generate route plans. We also teamed up with a couple of extras. So FarmScan Ag, company that makes ag tech, and Agri Epicenter, a sort of government-backed facilitator of projects. So we backed some other people, got some other people involved, and we had to generate routes to get around real fields, just like real farmers do. And this is what that looked like. You know, obviously, a lot of work went into this. The other thing I should say, and I don't say enough, is we failed a lot. In the grand scheme of things, we were successful. We've been successful the whole time. I'm very lucky about that. But that didn't mean there wasn't an awful lot of failure on the way. You know, the tractor didn't drive up and down in straight lines on day one. Well, it didn't drive up and down in straight lines in day 100, to be honest. But, you know, we failed a lot on the journey to getting to the point where we could put it in the field and do the press releases and get and do the thing we set out to do. But this shows the size and scope of some of our fields, and our little tractor driving up and down, drilling a crop. And these fields are challenging. We get really wet patches and all sorts of stuff. There's some spraying going on. So you can see we go through the whole sort of cycle of establishing a crop. And then we take that crop through to harvest. And now we have harvesting this we have brand new combine. You know, again, when you start and you're 26 and you ask people for things, most people say, go away, you're going to make us look stupid. One company, Izeki, that make these tractors, said, we'll give you a tractor. We're up for it. Everyone else told me to go away. Now, once you've become very successful and you've got publications in 85 countries around the world, everyone wants to give you farm machinery. So I get a brand new combine from Class that comes from India. You know, I get brand new trailers that come from Ivor Williams and all sorts of stuff. People throw things at us because now we're going to make them famous, or, you know, how to make them famous. So here we are, we're farming. What's going on here? Unloading on the move. The two machines are talking to each other. They're coordinating their forward speed. But what happens when we get to the end of the row? We don't end of the row. We don't want them to crash on the headland. So what we do, very simply, everything in Hands-Free is about breaking down the problem and finding the simplest solution. That's what we do. So how do you stop things crashing at a headland? You just put some space between them. So the tractor, when we get 50 meters from the end of the field, the tractor drives away from the combine. So the one does the turn and the next one does the turn afterwards. And then they line back up on the next row. Okay. So the amount of meetings I had where people went, wow, how are you going to coordinate turns so they don't crash? And people were getting, engineers just going down this rabbit hole of overcomplicating a problem that was solved by space. That's how we stop them crashing, space. Here combine goes, it turns around. It's got some, it's quite cool, this machine. This is a rice, sorry, I really love combine. This is a rice paddy combine. Comes from, as I say, India. It's on tracks to stop it sinking into the rice paddy fields. This is the only one in Europe. I own it. I'm very proud. So yeah, anyway, there we go. It's going to line back up on the tractor and it will go off again. We'll skip on. So in terms of, are we any good at farming? Well, we have yields of quite respectable, 9.2 tons of wheat, 6 tons of oats, 4.6 tons of beans. Beans is really good. That's a really good bean yield. The wheat yield is just above average. The bean yield is like well above average. The oats is a bit like near. But they're real yields that are really viable in a farm scenario. We did it again, or, you know, we did it a few years. So I'll just show you a couple more videos. This one's important. There's hours of footage. If you go on YouTube, you can watch it. But I've just picked out some bits. So this one's quite cool because there's two machines in the same field at the same time, speeding up our operations. So we've got one tractor doing a bit of soil prep and the other tractor drilling crop straight behind it. So in theory, you know, if you've got one person monitoring this task, there's now two tasks going on at the same time with one person monitoring it. You can see loads of people stood at the end. That isn't all my team. I never got to the point where I had that big a team. These are all students, because I think on this particular day, I was literally giving a lecture. This was going on. And I said, right, well, let's stop having a lecture now. Should we all jump out and go and see some tractors driving around the field? So that's who they are. They're all my students, or some of my students at one point. That same field then again, so the first two videos of the 1 year were both in the same field. And these videos I'm going to show you now are all from the same field just to keep it consistent. So this is that very same field, obviously later in the year being sprayed. It's not actually being sprayed. This is actually fertilizer being applied. liquid fertilizer. So you can see it dribbles on. It's not really sprayed on at all. It's dribbled quite coarsely into the crop because it wants to go down and into the soil. So there we go. And then that very same field being harvested last August. And you sort of see some of the stuff here. This has been put together by a student. And this is the sort of TikTok generation. So the videos all like cutty and things. It's not one of mine. And you can see that crop looks like wheat, and we take it away to the farm in a bigger trailer. And there we go. And then again, just to show you something a bit different, this is a combine cutting some beans, so it just doesn't look quite as pretty because beans always look a bit ropey, but these are doing good. This is a very good yielding crop. And you can see here, actually, what's going on here, quite interesting. There's actually someone driving this tractor. It might be me, can't remember. And this is something we're quite interested in, is the sort of co-robotics idea. The idea around, do we necessarily need to make a full autonomous system, or can we have a system where one person's driving one tractor, but there's other machines in the field that are doing their job by themselves, just being monitored from the one cab? So that's what's going on there. It's quite important to sort of say that, that fact there's someone in that cab isn't a failure as such. We've done lots of unloading without people in cabs, but it's quite nice to see that. It's quite a nice shot, that. This was the very last bit of harvest last year. I think, those 4 runs there were the last bit to do. So again, what were the sort of yields and things? Well, very similar again, 9.5 tons of wheat per hectare, just above average, pretty good. 4 tons of spring barley, again, a bit ropey. We had a bit of a tough spring year for spring cropping last year. Winter beans, 4.5 tons again, 4.4 tons. Really happy with that. This setup is achieving sort of 4 hectares a day, which is nothing. That's half an hour's work with a modern combine. But if I speak to my father about how he used to combine in the 80s, this would have been a pretty acceptable day for him back in the 80s, not that long ago. Things have progressed hugely. Massive, great combine with a 14-meter header I talked about earlier might do 100 hectares in a day these days. But, our combine costs £30,000 and theirs costs £1 million. Who's winning? Which brings me on nicely to some economics. So my name's on these papers. This is proper papers. This is proper like research, unlike my stuff, which is waving my arms. But this chap here, James Leonard de Boer, is an American professor who is internationally renowned for his work on sort of tech, economics of ag tech and precision farming. And he's been working with me for the last 3 years. And what he's done is produce a linear programming model, which basically models the effectiveness of our system, which is the orange line, versus conventional farming, which is the blue line. Now, to really quickly explain this, this is farm size, so the farm gets bigger this way, and this is cost of production. So you can see as the farm gets bigger, the conventional farm, it gets more profitable because the cost goes down. Okay, classic cost of production sort of curve, economies of scale. But what we can also see is, as in the conventional farm, as the farm gets bigger, this number here gets bigger because that signifies the size of the tractor being used. So as the farm gets bigger, you get a much bigger tractor. On ours, we have one machine, and then we go to 2 machines, and then we go to 3 machines. So rather than get a bigger autonomous tractor, we get duplicates and we build a swarm. The key fact here is it's 20 to 30 pounds a ton cheaper all across the board. But critically, it's cheaper at smaller farms. It makes small farms potentially more profitable. And that's something we didn't go looking for. It just fell out of the data, which is really important to me as someone from a small farm background.
So I just raise one quick point.
Yeah, go for it.
I won't labour this one. Are we talking about gross margins?
No, that's cost. That is purely cost of production. So the year that this was done, 2019, wheat was selling at about £185. Yeah. So you're saying, like, this dot here, you're leaving about 15 quid profit, whereas this one here, you're leaving £65 profit. Or something, no, £45 profit.
Yeah, but that's the margin, right? You aren't taking account of capital costs.
Yes, yeah, no, yeah, capital costs is included in this.
Okay.
Yeah, sorry. Yeah, capital is included. Land wouldn't be, but capital would, as in machines and things like that. Yeah. Okay. So going on from that, we've also looked at what effect. So here's the situation. We've got our 2 autonomous tractors in a field with a big conventional tractor. This thing weighs over 10 tons. Our machines weigh under 2 tons. 2 of these does the same job as the one massive one. We've got less compaction. We're in the field together. But critically, these 2 machines are more efficient in smaller fields. So the big machines need big fields, which requires us to get rid of hedges and field trees and biodiversity. Our stuff is not affected by field size anywhere near as much. So if we move to autonomous small machines, can we reinstate hedges? Can we reinstate field trees? Can we build biodiversity? Okay. And I always forget to make conclusions. So I'll kind of make a conclusion right now. For me, automation is an enabler of other things. Okay. For me, it's an enabler of sustainable farming. It's an enabler of building biodiversity. It's an enabler of electrification, because small machines can be electrified, whereas the massive machines can't. There just isn't enough energy density in a battery that makes it work. So automation is all about enabling. I might say it again later, but some other stuff we've managed to do. This is predicted work rates against actual work rates. And you see it's a really nice linear line, pretty much. What's that about? Well, at the moment, when you send someone to a field to do some farm work, you kind of go, oh, you're doing some rolling. You roll 2 hectares an hour, let's say, in the field's 10 hectares. It's going to take you 5 hours-ish. Go off and do it, or see you in 5 hours-ish. We can predict to the minute how long it will take, and to a pretty good accuracy, we get it right. So if we're trying to manage our farms in a more precise way, going back to this mission of precision farming, this is quite an interesting outcome that can I start to understand far more accurately how long things will take and how complicated situations are going to pan out. In terms of outcomes of Hands-Free Farm, loads more mainstream media. We were on we were on Country Farm, we've been on the Gadget Show, we've been on World News, been on the Farming Today program quite a lot, those sorts of things. So we kept that stuff going, as well as those sort of more academic things that we've actually done, which is good. We've kept the mainstream stuff going, because I'm trying to convince people that maybe being an agricultural engineer might be a good career. So I like these things. We've done some slightly unusual things. So this is Her Royal Highness Princess Anne, who is our Chancellor at Harper. And here's me showing her my robot tractor, which is quite cool. So now she doesn't just go and talk about it, she talks about it and comments on the fact she's seen it and how not very good it is, which she's done in a room with me in it several times. She said, this is, I've been to Harper, I've seen the robot tractors, there's a lot of work to do. And everyone looks at me and goes, meh. So there you go. Anyway, she's great. Also worked with the Royal Academy of Engineering. Last year, they did a thing saying, they took old paintings and they reimagined them for 50 years time. And, there's like proper real scientists, professors and things were asked for their opinions on what would be different in 50 years. And then they rang me, said, Kit, can you tell us how farming is going to be different? So what you'll see here is you'll see strips of crops. We'll come on to that in just a second. And you see a little combine that looks a bit like mine. And you see some drones and you see some wet bits, and you see a bit of rewilding and all these sorts of things that I discussed with them. And maybe automation is going to allow us to break our fields into smaller bits. And they included it in this cool picture. And I should know who did the original picture, but it escapes me now. Anyone arty might know, but I can't remember. I think it, no, I can't remember. Someone know? No. I think it might be Constable. Maybe. It's called The Wheat Field by somebody. There you go. What else have we done? We work with lots of people. So NFU Mutual insures the vast majority of farms in the UK. They want to know how they're going to insure autonomous machines. So they come and we've worked with them for like a few years, and they've come and seen it. And we are trying to, I'm trying to enable this industry to take on this technology. So I try to work with as many people as I can. Health and safety executive, they come and see the machines, and you think they hate it, but actually farms are one of the most dangerous places in our society. And the health and safety executive are actually far more positive than you could ever imagine about autonomous machines, because it means that people are going to be further from danger. Ofcom, telecommunication is really important for me. Cellular networks. I can't put a robot tractor in a field unless I've got a cell connection, because I need my RTK corrected signal, which comes via cell, and I need to be able to get data backwards and forwards to it. So that's really important. So I think we engage with Ofcom. And what we've done is we used to work on a government code of practice called automated vehicle trialing. Anybody can trial an automated vehicle if you follow this code of practice. You can download this code of practice. It's not very long. And you can make your car autonomous, and you can go and trial it on the Cirencester ring road if you wish. And you can go, oh, I'm following the code of practice. It does require you to have some insurance. So you've got to find someone who will insure your car to drive around the Cirencester ring road. And it does require you to have risk assessment. Anyway, this is fine for trialing, but it's no good for people who want to adopt it. So we lobbied the British Standards Institute to generate a standard on the use of agricultural robots, because there's no law. It's a bit of a grey area in law. There's nothing to say you can do it. There's nothing to say you can't. So we have come up with a code of practice, or I say I haven't really done it, but I lobbied some other people to do it. So now farmers can use this code of practice and hopefully have the confidence to adopt some precision farming, some autonomous technology. This slide will be really quick, but what you can see here is our very accurate tractor. Here's some telegraph poles that have never been crashed into. Here's a strip that we left, and we go back and we fill it in absolutely perfectly. So this just shows the accuracy of our technology. Now, this is some work done by a very internationally famous university called Wageningen, who anyone who may have come across the terminology of agroecology or regenerative agriculture and these sorts of terms, which are all about trying to build biodiversity, build soil organic matter, build soil carbon, build water holding through non-conventional, by meaning chemical means sort of thing. And the idea is if we put more than one crop into one field, we can get synergistic benefits between them. So we get legumes drawing down nitrogen that feed our cereal crops, is the one that I can most understand, because remember, I'm an engineer, not an agronomist. But the idea is if you have robots, you could have like these sort of patchworks of crops. But the things they've come up with, their sort of brainstorming, as it were, is all a bit sort of far-fetched and going to take a long time to get there. And I started thinking about this, and I was like, well, hang on, I've got a tractor that's really accurate. It drives exactly in a straight row, and it has a 2 meter wide set of equipment. So I can drill 2 meters of crop. I can then go back and I can apply chemicals on fertilizers to 2 meters of crop at a time, selectively as I choose. And then at harvest, I can go in and I can harvest 2 meters of crop as I wish. So rather than autonomous agroecology in 10 years' time, I said, well, we could do this now. So I went and spoke to my agronomy colleagues, and they all really love the idea of co-cropping. But we're like, we can never do it because there's no way we can get a tractor driver to drive as accurately as need and to remember to turn on the right thing at the right place and do the right stuff. And I'm like, well, my machine will just do that. So we have done it. And here is, it's a very small area of land, I have to say. It's like 1/2 hectare, like 1 acre, something like that. But we have, this is on the drilling day. We have a drill that's gone through, it's drilled 1 set of crops. This is now the 2nd set of crops being drilled, and then it comes back and does the 3rd. And this is what it looked like on Friday when I was at Harper, and I got in the field and I took a photo. So this is wheat, this is barley, this is beans, this is wheat, this is barley, this is beans. And they're growing next to each other. Now, you know, from an engineering point of view, we sort of completed it. We've done, I've showed I could do this. We can set up our equipment to farm in strips. Now, my agronomy colleagues are doing lots of work to see if it's any good or not, but we'll wait on the results of that. And we will harvest this come the summer. Okay, so I literally have a couple more slides, which I think basically takes me to exactly an hour since I got on the microphone, which was what I was told the remit was. So I'm pretty pleased with that. And I'm going to talk about some stuff just to finish off. It's got nothing to do with me at all. So this is about commercial adoption of this stuff. And this is a thing called FarmDroid. FarmDroid is from Denmark. It is a solar-powered autonomous seeding and weeding robot. And what you're seeing here is it planting seeds. And then because it has its highly accurate GNSS positioning, it remembers where every seed has been planted, and then it goes back through and it hoes around every single seed. Now, there you go. So this bit here looks quite similar to the thing I showed you at the start, the Garfield robot here, yeah? But this is not using vision. This is just using memory of where those plants are, okay? Now, what's impressive, or what for me is important about this, is this means I can pre-emergence hoe. So I can use a hoeing device to go in a field pre-emergence, and I can hoe. Because I know where the weeds are, so I just hoe around them. That is revolutionary. And just to take a little bit of credit, but I can't really take any credit at all, I had a conversation with my professor 10 years ago when I was a master's student, and we discussed, if we knew where every seed was, we could weed around it. And we went, yeah, we could do that. And it was on the list of possible benefits of ag robots. It went on the list. And then I sort of forgot about it. And then this company came out with a commercial system that does it. And by saying commercial system, I'm not joking. They have sold 300 of these units across Europe in the last 2 years. There are 16 here in the UK, growing crops for farmers profitably, arguably in some cases, well, no, in some cases organically, because of the fact it hoes, so you don't have to use ag chems. Other farms are using it in a reduced chemical way, so they're still going through with some chems, but it's reducing the reliance. It's quite affordable. It might not sound affordable, but they're about just shy of £70,000 for one of these machines, which is cheap in the world of agricultural machinery these days. And really importantly, I mentioned a second ago that automation may enable electrification. That thing is solar powered. Yeah, it's light enough. It's going slow enough. You have to, as a farmer, you have to get your head into a different headspace. This thing is really slow. It moves at 800 meters an hour. You know, rather than when I go in a tractor, I might be doing, 8,000 meters an hour with a seed drill. This thing's going 800 meters an hour. So it's going very slow. It's quite narrow. So things take time, but because they take time, the energy use is low enough that it can be powered by the sun. It's revolutionary. Major international developments. Now, I don't really know what they've done, and I don't really, frankly, care too much, but Google, or Alphabet, their parent company, the biggest company in the world, arguably, or one of them, has an autonomous farming project that they are funding called the Mineral Project. And they have robots in the University of Minneapolis developed. They developed them at Google. They sent them to the University of Minneapolis to be tested. The results of that is secret. I know they're there. I'm not allowed to know what the result is. But anyway, one of the biggest companies in the world has come into the world that I was banging on about when people said it was a stupid idea. Go away. It's quite important. There is some traction here. And very last slide, I think. In terms of the traditional companies, I could go through all of them and give you examples, but John Deere, the last time I had a proper meeting with John Deere was about 2018. And at that point, they were still telling me, even though I was known for what I did, that we're not developing autonomous stuff and we're not going to want to sell it to at least 2030. Then, with all the startups coming out and all the work we were doing and pressure starting to mount, in last January 2022, they suddenly came out with a machine and they said, look, we're going to sell 20 of these to 20 farmers that we know well by the end of the year. So they changed. They knocked 8 years off their predicted when we're going to do automation by. And this is one of the biggest ag companies in the world. So quite important that they've flipped their mindset and are now on board. So with that, thank you very much. If you want to know more, obviously you can ask some questions now, but do follow us on sort of social media or on our website and things like that, and you can learn more.
Do you want to take Nick?
Yeah, great.
All I can say is, as a small farmer and also an agricultural economist, I have a huge number of questions. I'm not going to put them all now. except just one point I was going to put to you.
Oh, no.
Being an old farmer,
Yeah.
is there now a possibility for old farmers with small farms to actually manage it themselves economically?
Yeah, I think so. I mean, so let's be real. The system I've developed is still not a commercial system, but it's not far off. It's with the want of a really good customer, we could get it over the line. And then you could put it to practice. But the farm droid, I say, if you wanted to grow onions, go and buy yourself a farm droid. It will grow 20 hectares of onions for you, and you just sit back and watch it.
High value crop would make
High
sense.
value crop, yeah.
Sorry, any questions before we have a tasty eats?
Still recovering.
Sorry.
It's not really your what 3 words address. It's an amazing success.
Yeah, so
Drone towers.
yeah, so I have a story about that. I'll keep it short, but I spoke at the Oxfam conference in 2018 in a technology session. And I followed the guy from What 3 Words, and I saw this and I went, oh, I better find our What 3 Words so I can make a joke about the fact that you can find some What 3 Words. He's a really nice guy that developed it. He's actually, he's quite a clever bloke, quite a nice bloke. I've met him a couple of times. And so we just scouted around, and Worms, Drones, Hours will take you to the gate into the original Hands-Free Hectare. So there you go. Yeah.
Okay. Yes.
Yeah. So I've made a kind of point in my career of not banging on about replacing humans because it's just bad news. And as I hope you can see, I try to be optimistic is my thing. I like to be endlessly optimistic whenever I touch you on this or whatever. I'm optimistic. The world is a good place. We can solve problems. We can do it positively. And the minute you get into the trap of talking about jobs and immigration and stuff, it all just becomes very negative. But yes, absolutely. So there are, if you take the fruit example, you hear all the time about fruit growers can't get enough staff anymore, migrant labor. The problem is, when I started Hands-Free, there was a lot of projects trying to pick strawberries because picking strawberries was the glamorous bit of the job. Everyone said, we don't have enough migrant strawberry pickers. So when people did funding applications, they said, well, we're going to pick strawberries. Problem is, picking strawberries is really blooming hard. Yeah. Now, if it wasn't for the way that funding's structured and the glamorous thing gets funded, what the better question would have been is we actually don't have enough people to sort and logistically manage fruit on our fruit farms. Because only about half the people on a fruit farm are picking fruit. The other half are shuffling it around and punting it up and all of the tasks, which are far more easy to automate. And for about 4 or 5 years, all the funding went into the hard bit. And I was banging on for ages whenever people ask me about fruit. They're doing the wrong thing. They need to do the logistics. And then in the last 2 or 3 years, there's now suddenly lots of companies doing the logistics. And if you go to a fruit farm now, it's probably fairly likely you'll see an autonomous machine trundling up and down, carrying stuff around. So you've still got people picking, mostly. There are some that are starting to adopt robots, but mostly it'll be manual picking, but machines helping to get over that labor shortage, The same, lettuce growers and things like that, the farm droid is coming in there. And my wife used to work on a farm, they grew flowers. They used to manually hoe those flowers using migrant labor that was drying up. So they bought a farm droid, and now the farm droid grows their flowers for them.
Fantastic. Right. Well, Kit, thank you very much. Assuming we now go and have our food. Thank you very much for coming this evening. Absolutely fascinating, and also your very infectious enthusiasm.